Okay, welcome back. We will continue with the last part of question 2, and that is question 2.3. Okay, so we are going to look at an annexure, and for this question, we will just jump straight to it, and we'll be looking at annexure A. All right, so just so that I do not confuse you all, we will read the questions first and then we'll look at the information that is given to us. All right, okay, so it starts with the first question 231. Identify the tax bracket that Mike will use to calculate her income tax. All right, so we have to identify, it's 3 marks, right? This is clearly, it's probably our favorite topic, taxation. Yes, taxation and tax brackets. Okay, so we have to identify the tax bracket that Mika will use to calculate her income tax. The second one is calculate Mika's annual tax payable for the year 2023-2024 tax year. Okay. So there'll be calculations and just identifying. Not too bad. Okay, the information goes as follows. Mika is 45 years old. Very important to note. And he earns a monthly taxable income of 39,275 Rand and 85 cents in the year 2023-2024 tax year. She does not belong to a medical aid. All right. Okay, so now we'll just jump straight into our addendum and look for annexure A. And there we have it. All right. So having noted Mika's age, we know that Mika is 40, just to be certain there. She is 45 years old and she earns 39,000. Okay, so it's an approximate of 39,000. She's 45 years old and earns about 39,000. I'll just write 39K per month. Looks like she's doing very well for herself, and she does not belong to any medical aid. Okay, so she does not belong to any medical aid either. All right, so we have to first identify which tax bracket she belongs to. So we have the tax bracket over here. Now we need to identify which one she belongs to, noting how much she earns per month. So now please note that the tax bracket only shows for annual income. So this is annual taxable income for the year, right? So meaning we have monthly, we need to then calculate. So yes, I did say in the first question, we have to identify, but looking at the mark allocation, seemingly we have to calculate so that we can identify the tax bracket that she belongs to. Okay, so having noted that she earns 39,275.85, we have to multiply it by 12 months. All right. Okay, so we will calculate that. 39,275.85 times 12, and that brings us to an annual amount of 471,310.20 cents. Okay, so that is her annual income, 471. So now let's go back to the tax rates, to the tax table. So having noted her income, her annual income, which tax bracket does she belong to? So we need to look at this column. Okay, so please note that the amount that we calculated is taxable, meaning it is subject to be taxed. it must be taxed, meaning the government must take a portion, calculate the portion that must go to the government. All right. So make sure that you quickly identify that the income is taxable. Okay, so since it is taxable, the amount 471 is correct, and she belongs to which? Okay, A is greater than, so it doesn't get there, 400 and. So it seems like she falls in tax bracket C, which is between 370K to 512. So she's in between there, meaning this is the tax bracket that she belongs to. Tax bracket C. So we've identified which tax rate we will be using for her. Right. And just a note, if you do get the first answer incorrect, the second answer will be incorrect as well. So just make sure you calculate and check properly that you've found the correct tax bracket. Okay. Okay, so now that we've figured that out, let's go to the next question. It says calculate Mika's annual tax payable for the financial year 23-24. Right, so we are going to the annexure A. Okay, I'm gonna move this over here. Right, so we've identified how much she earns per year that is taxable. That is 471, 310,020 cents. Okay, so this is how we then calculate the tax amount, the tax payable. So this is how much tax she must pay or she will be deducted. Okay, let's start. So since she falls under this bracket, we're going to use this tax rate. So we're going to use 77,362 plus 31% of taxable income. So how much is the taxable income? We said it's 471,310 and 20 cents. So that is the taxable income, right? Taxable income above 370, 70,500. Okay, so we'll just of taxable income above 370,500. Okay, so I do urge everyone to make sure that you write the tax rate fully as it is once you start to calculate. Okay, so that you don't get too confused. All right. And then from here, we know that the 77,000 is a fixed amount that she must pay. And the next calculation after the plus, right, is it's only 31% of the taxable income above 70,500. Okay, so anything above 370, which is above her, which is which does apply because her taxable is greater than 370, right? So meaning this is how we'll do it. So let's just follow along very carefully. So it's 77,362 plus 31%, which is also 31 over 100 of multiplied by, we'll put brackets here because there's a sum that we have to work out. So we know that the amount that she earns per year is 47310, 20, but we want the one that's greater. So we want the difference between that amount and the maximum she must pay, which is 370, 500. So we want the difference. So that's how much she will be paying 31% of, right? So we know BODMAS, we must always calculate the sum that's in brackets first. Okay. So please don't get tired. You must always, please try to rewrite everything to avoid making mistakes. Okay. So it's 471, 310 and 20 cents minus 370, 500. So that is 100,810 and 20 cents. Okay, so that is the amount that we have to get the 31% of. Okay, so we're still not done. We'll still put that 77,362 plus. Okay, so now we have to calculate that amount. Okay, so we have to calculate 31% of the 100,000, which brings us to 31,251 and 16 cents. Okay, then we have, now we just add. Now there's less stress, right? So we have 31,251 and 16. I think from here we can just calculate and give the sum, and the answer will be 70. Okay. Right. So that's a total of 108, 608.13 and 16 cents. Okay. So that is the amount, or the amount of tax that she will be paying. Okay. So I just want to move. Right. Okay. So that is the amount that she will be paying. Okay. Please don't mind this. I'll just scratch it. But we know where this amount comes from. All right. Okay. So we're still following each other, right? Okay, so following along. Now we also have tax rebates, right? We have tax rebates table. We also have a tax thresholds, right? So if they are under, or if they primary tax rebates, it's for people that are, so this is an amount that the government relieves you of. Meaning, so from that amount that she owes of the tax, okay, so that amount that she owes, which is 108, right? So that's the amount of tax that we've calculated. So it's 108, 613,16, right? So that is the amount of tax that she would pay per year, annual. Please note annual, not per month. Because we have tax rebates, we have to minus the tax rebates because it's a relief. So it's to relieve you from the amount of money that you were supposed to pay, but you won't pay. So they relieve you of 235. So that's what a tax rebate is. Okay, so that's a tax rebate of 17,235. And we also have tax thresholds. Okay, that is, okay, so we'll minus the first amount, 613,16 minus 17,235. All right. So the amount will be a total of 91. 378 and 16 cents. So this is the amount of tax that she will be paying per year. Now, it's important to always go back to the question so that we find out what the question really is asking for, because sometimes the question is asking for the annual tax payable or the monthly tax payable. So please do make sure that you always go back to your questions. So the question is asking for the annual tax payable. So we are in the clear there. And we have our answer, 91,378 and 16 cents. So that's how much tax she will be paying. And because she is not part of Credit Medical Aid, we do not have to use this table. All right. Okay. So we will move on to the next question. I think we did that one very well. I do hope you're still following along. Right, so we're going to go to question 3, which also requires an annexure. You know the drill. We start with the questions. Okay, we analyze the questions, we understand the questions so that when we look for the information, it's easy for us to find. Okay, so 311 says identify the year, right, in which there was a decrease in the number of employees. So the number of employees in the Pick n Pay stores for the first time. Okay, so there's a lot of detail in this question. Make sure to highlight it. Read it twice or thrice if you may have missed something. Okay, 321 or 312 rather, it is projected that the number of Pick n Pay stores will increase by 95.39% from 2023 to 2032. Now, determine by means of calculations the projected number of Pick n Pay in stores in 2032. Okay, so we're given an answer. So this is an assumption. Right? So this is just a projection. It will increase by 95.39. Okay, so it will not increase to 95, but by 1395. Okay, so that is, we have to prove, this is a question where we have to prove whether the statement is true or valid or invalid. Now let's go to 313. An analyst stated that ShopRite employed more employees per store than Pick n Pay. So this is another one. So an analyst said ShopRite employed more, right? So than Pick n Pay. So we have to verify showing all calculations whether the analyst statement is valid. Then we have the last one, determine as a percentage. As a percentage, the probability of randomly selecting a year where the number of ShopRite stores is fewer than 2,000. All right. Okay, so we're going to look at Annexure B, which shows two graphs. Graph 1 shows the trends in the number of ShopRite and Pick n Pay stores for the period 2014 to 2023. And graph 2 shows the trends in the total number of employees in these two stores for the period 2005 to 2023. All right. Let's go to the annexure. Okay, I'm going to rotate it. Yes. Okay, so we have our annexure B, and we're going to look, this identifies question 3.1. All right, so this is just 3.1. Let's just note. Okay, now let's see. Let's go back to the questions. It says identify the year, right? Identify the year in which there was a decrease in the number of employees in the Pick n Pay stores for the first time. So there must be a decrease in Pick n Pay for the first time, and we must identify a year. All right, let's go back. Okay, so we're looking at graph 1, which is the trends in the total number of stores. Okay, we should be able to analyze a table by now, but I'll walk us through it. So we do have it's a line graph. One is a dotted and one is a straight line, right? So just to show us the difference with the key Pick n Pay is the dotted, the straight line is ShopRite. So for the question, it's asking for Pick n Pay. So they want to see a decrease for the first time. So we're looking for the year, right? So where was the decrease? We need to look carefully at the trend. Okay, so here it seems to be it seems to have picked up quite a bit, and this is how we find the trend. So it's going, right? This actually makes it much simpler to see if there was a decrease and where was it. Okay, I really hope this helps. Let me just make the line a bit thicker for us to see. Okay, so we'll draw a straight line to show us where the dip went. Okay, so where do we see the dip? Okay, so as we can see, this is a straight line. There was a bit of a dip right over here. So it was a slight increase, right? And it went up. Okay, so it was a gradual increase. It was a very gradual increase, but the greatest dip that we can see is actually here in 2025. So this was in 2014. This is when it began, and it it was increasing, right? The trend was increasing, meaning the total number of stores kept increasing um, until a certain point where they no longer increased. So let's look at these points, all right? So which one is the lowest? Okay. So this is how we can identify which year showed the greatest decrease rather, right? So as we can see, it moved along quite nicely and increased gradually until this dip. So there was a nice dip over here, right? So it's below the line. So I used the trend line to help us identify quickly. So this straight line is called a trend line. So there was a great dip here. So the space between the trend line and the dotted line is a bit wide, right? So, and then we also see a lot of space over here as well. So there was a bit of a great decrease, right? There's a great decrease, but we could actually say that the greatest decrease was right here in 2020. Okay, it was in 2020, and then the rest of the year it became wider, right? So the decrease kept going, but it was very inconsistent. So from here to here, it was very inconsistent. So the answer will be 2020. Okay, so that is question 1311. All right. Okay, so we'll move on to question 32312. Okay, so we are at 312, and the question is, it is projected that the number of Pick n Pay stores will increase by 95.39% from 23 to 32, year 32. So this is an assumption or a projection that we have to determine whether it is valid or invalid, right? So the answer must actually give us 95.39%. Okay, excuse me. So now we will go back to, we're only looking at the projected number of Pick n Pay stores. So we're looking at the graph 2 to see whether it is correct or not, right? Okay, so we're looking at Pick n Pay. There are 90,000. Okay. Right. Okay. So we're looking at stores. My apologies. So we're still looking at graph 1 rather, and we are still looking at Pick n Pay, and we're going to determine by means of calculation the projected number of Pick n Pay stores. Okay. So in the beginning of the year, or in the beginning of 2024, okay, in 2014, there were about 1,128, and now we have in 2023 it's 2,204. So they want to see a projection of the year for 32 based on this data. So how do we find out whether it is 90%, 96%? Okay, so we'll just note down the number 2014 and 2 to 4. This is 2023. Okay, so we'll need to see if it will be this projection. So mark allocation is 3 marks. So not a lot of calculation is required, but let's be careful. Let's look closely. So we need to see the difference in the years, the increase of the stores. So the difference is 2,204 minus 1,128, and that is 1,076. Okay, so that was the increase. Okay, so we need to base it off the previous, right? We'll base it off the previous. All right, so we'll say divided by 1,128. Okay, so this is the difference. I'll just give us a quick formula that we might know actually, and we will say multiplied by 100. This should give us, okay, 95.39%. Exactly that. Okay, so the formula to this is you find the difference between the data that was given, the data periods, and once you found the period, which is the difference rather, which is 1,076, you divide it by the old or the old year, right? Or the old amount, which is 1,128, because 1,128 is from 2014. So you always use the old amount, not the new one. So you divide it by the old amount and you multiply it by 100, and you find it is in fact 95.39%. So we're basically validating the assumption that was made, or the projection. Okay, we'll go to 313. It says an analyst stated the employee, ShopRite employee employed more employees per store than Pick n Pay during 2023. Okay, so we are looking at the next trend graph. So, right. Okay, to make it simpler, I'll just write ShopRite. Okay, so Pick n Pay is 90,000 and ShopRite is 15326. Okay, we'll go back. Okay, so another important thing I usually do is go back to the question. So the analyst stated that ShopRite employed more employees than Pick n Pay during 2023. So we want to see during 2023, right? So the total number of employees started at 50. So this is about 50, and this is about 90, right? So it's 90. So we have to look at the increase, how much it increased by. Okay, so it's going to require a lot. Okay. All right. Okay, so that one is quite simple. Since ShopRite is 153 and Pick n Pay is 90, we need to find out whether it is correct. So we need to validate the statement and also validate this fact, these amounts, right? So which is why we do need to closely look at the years. So we look at the years 2020, 2005 was about 50 for Pick n Pay, and it increased up to okay. So this is for Pick n Pay. I'll use pink for Pick n Pay. Right. Okay, and then I will use green for ShopRite. Okay, we'll use 2004, which is in the middle. And right here, it's about, all right. Okay, so having looked at the number of number of employees that ShopRite has in comparison to the number of stores that they've opened up until 2023, we need to find the average number of employees that they've hired as the number of stores have increased, right? So we'll start with ShopRite and find the average to find if the average is actually greater than Pick n Pay. So we'll say 153,726 divided by 354,353. Okay, and this will give us 43.38. So I'll just put 388 to 3 decimal points, and we'll do the same for Pick n Pay. It will be 90,000 divided by 2204, which is equal to 40.83. 4. Okay, so it seems like the average for ShopRite is greater than Pick n Pay. meaning, can we validate the statement? The statement said ShopRite employed more employees than Pick n Pay, per store than Pick n Pay. So per store, for each store, they employed at least or an average of 43 people in ShopRite. And in Pick n Pay, at least 40 people were employed. So the greater average, which is a ShopRite, it does actually validate the statement that ShopRite employed more employees per store compared to Pick n Pay. All right. Okay, so we're going to move on to the next question. So it says determine the probability of randomly selecting a year where the number of ShopRite stores is fewer than 2,000. Okay, so the number of stores, select a year, the probability of selecting a year where the number of stores is less than 2,000. Okay, so let's check that. Um, we're looking at ShopRite stores. That's what we're focusing on. So ShopRite stores is the top line. Okay, so for ShopRite stores, what's the probability that there are less than 2,000? So which years were there less than 2,000 stores? Okay, so let's look here. Let's look closely. We have 2014, which had 1,081, and 2015 also had less than 2,000. So remember, this is the benchmark that we are looking at. So the probability that the ShopRite had less than 2,000 stores. So if it's greater than 2,000, then it's not part of the probability. Okay, it's not part of the pool. So we have 2014, which is less than 2,000 stores. 2015, ShopRite still had less than. 2016 as well, it also had less than 2,000 stores. But when we get to 2017, it is above 2,000 stores. So it means it's a probability of three years out of how many years? 1, 2, 3, 4, 5, 6, 7, 10 years. So it is the probability of 3 over 10. And the examiner wants this question answered as a percentage. So we're not done. So it's 3 over 10 divided by, that's about 30%. Okay, so 3 over 10 is 30%. Okay, so 30% is the probability that we have here. Okay, please do make sure, just double check your answers. Don't be lazy too. Okay, we're going to move on to the second part of question 3 still. Question 3, we'll start with the questions as we have established a system. All right. 3, 2, 1 question says, write down the number of customers that represent the sample size and the number of customers that represent the population size. Okay, sample size and population size. Okay, 3, 2, 2, choose the correct option, A, B, C, D, or E, that represents the stage in the data handling process that uses the measure of central tendency and spread. Okay. 3, 2, 3 says, give a reason why the value of 1 to 7 is considered to be an outlier in the data set. Okay, then we have 3 to 4 shown below in rank order is selected data of the time spent in the store. Okay, and an incomplete box and whisker plot of the same data. Right. Okay, so we have the data and the box and whisker plot, and we will answer the question. So we'll start with, so here are the questions to follow. Yes, A and B. All right. Okay, so let's look at the information we're given. A study relating to the amount of time spent in minutes is a selected number of customers in a store. In a store was conducted on a particular Saturday. On that Saturday, a total of 12,342 customers visited the store. So this data represents, what does this data represent? The amount of time in minutes, right? Only by a selected number of customers in a store, all right? So only a selected. And on that Saturday, a total of 12,342. So in that store that day, 12,342 people or customers visited that store on that Saturday, but only a selected number, which is this number, that was asked questions or just surveyed on how long they spent in the store. So only this amount of people we will use the data to answer this question, not the 12,342, because this does not amount to 12,432. Okay, so which brings us to the first question, right? It's a very important one for us to understand. So it says, write down the number of customers that represent the sample size. Okay, so the sample size is the number of people or the number of data, people that were asked within that survey. So this is the data that was used, which is right here, that is highlighted in the pink. So this represents the sample size. Okay, so if we're to count this in rows, we see that's 4. In 4's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so it is 4 multiplied by 8. That is a sample size of 32 people. Okay. Okay, so that's the sample size that we'll be using in this question. Okay, and it wants the number of customers that represent the population size. So out of how many, right? So in a total, the population of 12,342 customers. So this is the population size. So in a total size, it's a total amount of 12,342 people. Only 32 were surveyed or selected to conduct the survey to find out how many minutes they spent in the store. Right. I do hope that makes sense. I rambled a bit there. Okay. So we have the answer to question 321. So all you had to do is write down the number of customers. Okay. So we will move on to 322. Okay. So 322, it says choose the correct option, right? So this is where we choose which one is the correct one, right? That represents, or this represents the stage in the data handling process that uses measures of central tendency and spread. Okay. Measures of central tendency and spread. Okay. So this one, this is where we, it's basically where we talk about the mean, the median, and the mode, to show us how the data is spread, or disperses, right? So what does this mean? Which is the correct answer out of the 5 options? So is it collecting data? Is it classifying and organizing, summarizing, representing, or analyzing, right? So this is a stage where we are summarizing data, okay? Right, so this is the part where we calculate the mean, we calculate the median, and the range, right? So this represents the summarization of data. Okay, let's move on to the next question. The next question is 323. This says, give a reason why the value of 127 is considered to be an outlier in the data set. Okay, so let's look at 127. When we analyze, quickly observe the range or the consistency of the data that we're given here, most of it does not exceed even 80. So the reason why it's an outlier is because it is the furthest away from the average size or data size that is used. So it's way out. Okay, so a reason you can write, a more clear reason, is the value 127 is very further away from the average data set, right? So it's extremely out of the data set. So that is why it's an outlier in the data set. Okay, so that's the greatest number basically. It's the greatest data in the data set. Okay, so we'll go to 324. Here we'll be looking at the box and whisker of this data. Okay, let me move it up, move it down a bit. Okay, so this one says, shown below in rank order is selected data of the time spent by customers in the store and an incomplete box and whisker plot of the same data, right? So just to make it simpler, they've brought down the data that was used up in the questions above. Okay, so the first question says, calculate the value of the upper quartile, which is Q3. Okay, so here's Q3. Okay, we need to first know the values on the box and whisker. We must know them, right? So we know that the line here at the end, the first the first line represents the minimum the minimum value of the data set. And the one that follows in the box is it's Q1. So it's lower quartile, right? So it's Q1. And the middle one is Q2. And then we have Q3, which is the upper quartile, and 127, which is the maximum, right? So the distance is very, very wide, okay? So that's a very wide distance. So now we have to calculate Q3. So we need to calculate the value of Q3. Okay, let's get on with it. Okay, so we're given we're given Q1, which is 15. We are given Q2. So Q2 is actually the middle number, right? So it's the median. Q2 is the median number, the number in the middle. Right. So and then we have the maximum number. Okay. So the best way for you is to rearrange this data set in ascending order. So the data set has already been reordered, ranked in order or in ascending order. So here you just need to find the Q3, right? So the longest way that you can do it, we will not do it in detail, but I will show us how. Okay. So in this data set, you must have a median number. Okay. You must have a middle number. So if we know that as we counted before, that the data set here is, or the sample size is 32. Yes, it is 32. So the median number of 32, because 32 is an even number, it will be it will be two values in the middle divided by 2. That will be the median number. Okay. And then in the first, so that will be two middle numbers divided by 2. That will be our middle number or median. Okay. And then we have a data, so we still have data set here on the other side, right? Obviously including the maximum and the minimum. So we'll start with this side. How do we calculate the Q1 from this side? We find the middle number within this data set on the left. Okay, so you find the mid value of data in the lower quartile. Okay. That's exactly what we do there. And here we find the mid value of the upper quartile. Okay. So here we find the mid number of the upper quartile. And obviously we have the maximum there at the end and the minimum there at the end. And that would be your Q1, Q2, and Q3. Okay, so that is how you would find your quartiles. Okay, so that's how you'd find your quartiles. It is just it's a bit of a tedious process. However, I do hope that I was able to specify and clarify it for you easily. But yes, that is how we find it. And just make sure that whatever number you find, it must be between 20 and 40. Okay, then that's how you will find the quartile, the upper quartile. All right. Okay, so we'll go to B. Vuyo stated that if the outlier value was removed from the data set, the new interquartile range would be 13. So what's the interquartile range? Interquartile range is Q3 minus Q1. That is the interquartile range. So that is how you find it. So in this case, you would have to remove the maximum to actually validate his statement. Removing the maximum number, which is 27, then you would follow the same process as we found here to find the quartiles, Q1 and Q2 and Q3. But to find the interquartile range, you say Q3 minus Q1. So whichever amount that you found here in the first question you can't use that one, but you have to find out the new one where once you've removed the outlier in the data set. All right, so that is how you would calculate. Okay, all right, so we'll go on to question 4. Okay, let's go to question 4.